As mentioned in Roger's product update, one of the new features in the 10.3.3 release is the enhancement to the Select class. In this next presentation, we explore these new features. Our next presenter started providing professional services to Synergex customers in 1995 and has successfully completed numerous projects around the world with Synergy customers. His pivotal role as Synergex technology evangelist allows him to work closely with customers and Synergex development team to help accelerate the customer adoption of Synergex technologies. Please welcome Synergex technology evangelist Richard Morris.
Thank you. Good morning, everybody. It's very strange. This is probably my 20th conference, and it's the first time I haven't got a tie on, and I haven't got a jacket, and I haven't brought a suit with me, and I absolutely feel naked. Luckily for you, I'm not. Thanks for that. Okay, we're going to talk about the Select class and the enhancements to it. Before we get on to the Select class itself, the enhancements to it, I thought about asking who's using this technology. And I'm not going to. I'm going to go through it and maybe ask at the end. Because I want to start off by giving an overview and a refresher for those who are using it and those who are not, a sort of overview of what the Select class is. It's basically built up from various sort of subclasses where you can select data. You can tell it where you want to get the data from. You can tell it how you want the data to be gotten, and you can also tell it how you want to then see the order of the data. And then going to go on to why you should be using the Select class, and then we'll hit the new technologies and the new capabilities with the Join capability. And I'll also show you and just mention a bit about the analysis stuff that Roger had just been talking about. The vast majority of what I'm going to be doing, luckily for you guys, is not too much talking. I've got a few slides, but plenty of demos. The Select class then essentially allows you to provide or utilize SQL-style coding to get at your Synergy DBMS data. Some people might know it as Synergy DBS, some people might know it as ISAM, some people might know it as index files, but basically, unless you're using a relational database, if you're using our proprietary data storage, it's our Synergy database management systems, which are ISAM files, which are your index files that you store on disk. And you probably point to them in various different ways. You use hard-coded paths, I hope not, logicals, you use XF server, all that kind of good stuff. Doesn't matter with the Select class, however you do it, it's all supported. So with the Select class you define where the data is coming from. That can be a file name, it can be an open channel, we'll get onto that shortly. You tell it what data you want to actually see, and then you iterate through the results. Iterate through the results just means you go in a loop and say, give me the next, give me the next. Not like a read and then a read S, where you have to read the first record that you actually want, then read S to the next one and check, is that the one you still want, and is it in range, and is it containing the information you want for this particular query? Yes, it is, then I'll use it. No, it isn't. Okay, get the next one. Am I at the end of the file? Have I had an error? You know, it's quite a complex set of lines of code to actually just get a few lines of data. And the downside, obviously, with that kind of scenario is you're bringing all the data from the file into the program to be able to then say, yes, I want it, or no, I don't. It's better to make that decision inside, basically, the database, and especially in a client-server environment. So we have the Synergex SynergyDE select.select class. The Synergex.SynergyDE.select is the namespace, select is the class. So, as I said, you tell it how you want to get at the data, a channel, an opened channel that you've previously used in your application. It could be a file name, it can take a literal file name, it can take the results of a function if you want to call a function that tells you where the logical is, tells you what the company number is, or the company letter, all that kind of stuff, what the folder it should be in, what server it should be on, etc. You can then tell it to filter. So you tell it, I only want this subset of records from the file, so don't bring everything to me, just bring back the ones that I'm asking for, and then you can also tell it to order them. So instead of getting them into your program and saying, well, that one's less than that one, so I'll move that one above that one and then move that one down, it does it all for you. It's an awful lot quicker. And it's also obviously more efficient than reading the data from the server or from the file, putting it into another file to then do a sort on it, to then get the data in the order you want inside your application. Now obviously if you've got a key, you can do ascending and descending key reads if you're doing normal sort of language I/O, but the select class allows you to work on non-keyed fields as well as key fields a lot more efficiently. So the from class allows you to determine, as I said, where to get the data from. So you give it a file name and it'll open that file. It'll give you you can give it a channel if you've previously opened that channel. That's more efficient because there is an overhead in opening a file. So if you're doing repeated select queries, it's to the same file. The recommendation is to open the file in input mode and then use that, and then you're not reopening the file every time. There's lock options as well, and there's lock options because although I'm not going to demonstrate this today because I'm all about selecting and joining things, you do have the ability to do updates through the select class, which is a bit strange that it's a selecting class and you can do updates through. But if you pass a channel or a mode that says I want update, you can actually force updates to the file, and that's not to a single record, that can be to some or all records that match a particular workload. So it's a quite powerful feature, but we're just talking about selecting at the moment. And then you define, for the from, you define what the data is. Well, that's going to be a record area, or it's going to be a structure, or it could be a group area that defines that's the layout of the record area that I want you to return from the file to the program. Okay? So you've told it where the file is, you've told it how you want it opening, and you've told it what the data is going to look like. The easiest thing then is to go straight into a demo. So instead of putting code on the slides, I'm just going to run demos. I've put a couple of links down at the bottom. The GitHub link, if you wanted to, you could actually do this now. I don't want you to, please don't. But every line of code, the whole Visual Studio project that I'm going to go into and show you the 10 different demos I've got, is all on GitHub, and it's called Synergy Select Examples. So that's the repository. Feel free to get it after the conference, look at it and do what you like with it. If you want to just look at the code, that's fine, you can. If you want to actually run it, if you visit symphonyframework.net, there's a very simple examples installer on there that just saves away a couple of files or installs a couple of files, data files on your system. And that's just the sample data that I use in an awful lot of my demos. And it was interesting the other day because Bill Mooney was talking about a presentation that we did back in 1900 I think it was, and it was down in Florida. Some of you would have been there, not many because you're all so young now. And it was when we had I think it was in Kissimmee, and we had a motorcycle come onto the stage. I know you were there, Steve. And we had posters, and it was all about motorcycles. And it turns out I'm still using the same data, just in a different format. But hey, life's for a living. So, I'm going to try and show the code. It's all in Synergy.net, although all but one example runs completely on all platforms. Don't think this is a Synergy.net capability only. It's not. It's completely cross-platform. It works in traditional Synergy on OpenVMS, on Unix, and on Windows, and Synergy.net on Windows. That slide that Roger showed is actually a piece of code that's very similar to what I've got here that I gave to Roger, and we checked, and yes, it built and ran on OpenVMS, that join code that he showed. So, very, very simple then. That is our select statement there. We're selecting, we're creating a new select with a new from, I'm passing in the file name, and I'm defining the data format or the data layout that wants to come back. I've put it in a for each. This all works in traditional Synergy. This is OO coding, but it's traditional Synergy. And I can iterate through that list, and for every item that comes back, I'm going to do something with it. And this is going to bring the whole file back. Okay? I'm not putting any selections on it, any filtering, any work clauses, etc. All that's doing is then, for each item, it's putting it into a list. So if we just quickly run it, I'm not pretending that these demos are startlingly, fantastically wonderful, but hopefully they'll give you a good view of what we can do. And then you get a list. So it's got a simple grid, and you've got every item that's in your file has been brought back, and everything's nicely formatted. Simple as that. So there's no reading a record, no read-essing, it's all sort of done for you under the hood. And in a client-server environment, there's no difference really from a client-server environment because you're asking for the whole file, you're not doing any filtering. I shall shut that down and I will try and go back to my PowerPoint. There you go. So, we can get the data. Now we want to filter it, because this is one of the powerful features of the select class, in that we can say, on the server, work out what actual data I do want to see in my program, and just bring that back to me. So there's 150 records in that file, something like that, I'm not exactly sure. I may only want one of them. I may only want 10 of them. So I want to filter on, say, for example, the group code, of which there's 20. I don't want to bring 100 back, and the group code might not be a key, might be, but it might not be. So if I'm certainly doing non-keyed reads, I would end up bringing the whole file back if I couldn't filter it on the server. We use the where clause then to filter it and say, this field equals a value, or this field is not equal to a value. And you can concatenate where clauses together by casting all the if this field equals that, if this field equals that, together and cast it with the where clause, so you can do multiple comparisons. As I said, not a huge amount of slides, so we're going to go straight back into the demo. So all I'm going to do now is make this the startup project, and we'll go straight into the code. Now, it looks similar, doesn't it? So what I've done is I've set up Visual Studio really carefully, and I've added white coloured code. It's a fantastic new option that they've got in Visual Studio that Marty added, and it means that I can pretend that it doesn't. No, I'm joking. The layout now, it brings up the same list at the top, but now at the bottom I've changed the user interface to be able to filter things and select things at the bottom. So I've got two selects in here. There is no concept of white code. In case anybody starts asking, there is no concept of white code. Okay, so what we're doing here, exactly the same structure. We're doing a for each that returns our item that we can iterate through the new select. We've got the same new from, but now we've got a where clause to say the ID equals something. Now I'm setting it to a field, so I'm hoping that I have a user interface that allows me to enter something in and press a button, and I'll then filter on that field. So let's have a look at that in run mode, as they say. We'll see the same list at the top, but the window will be slightly different. And if I pick one of these, so I'll do DID02 and hit the button. So it's doing the select, it's where claused, and it's just bringing the one record back. Okay, it's not a stunning demo, but it's showing what the code is doing, and there's no smoke and mirrors in here because I can change this. CS. Okay, so it still works if I pick another one. Now, at this point in time, if it was a real live demo, I'd ask some random person in the audience to shout out a code, but we'll not need to do that. We'll just close it and say thank you very much. It does really work, honest. So that's a very, very simple example of the where clause. And obviously, that was on a key read, and it was looking for a specific record. I was only getting one back, but it still allows you to do the same sort of functionality. Obviously, there's a lot more we can do with the where clause. We can do things like between. So we can say a numeric value is between 10 and 20, for example, 5 and 7. That numeric value may or may not be a key. We can say contains. Therefore, an alpha string contains the word wibble, wobble. Okay? It's not a key. It would never be a key. A description in your file would never be a key. But we can search through the file very quickly and just bring the one or two records or however many records back to the client instead of you trying to troll through the entire file. We've got the in. The in says a list of values. So if the field has this value or this value or this value or this value, so you can specify a list of values. As well as the where, we also have no case where, which works exactly the same as the where, But guess what? There you go. At least one person's alive. It's non-case sensitive. So if you've got mixed case in your descriptions, you can use a no case where and it contains, and you'll find the data that you want. Guess what's coming next? A more meaningful demo. Well, a demo anyway. Let's not stretch it too much. Advanced filter. I hope you're all writing these down. You could be coding this yourself straight away. Again, we've got the white code. No, again, we've got the list at the top. And now we're going to do some checking. Obviously, we've got some sort of user interface that we may have a checkbox on there called case sensitive that allows us to determine that we want to do a case sensitive or insensitive search. So there's the case sensitive. And then depending on that, so we'll use either the where or the no case where. And we're going to filter the description contains some sort of text. Ideally text that we've just entered into the window. Description's not a key, don't forget that. So let's run that. Quick build and it should run momentarily. Similar interface to our last demo, you'll see a pattern really. So we've got all these records up here that we've returned, so that was our top select. So we can say, for example, bolt. And if I do that, it doesn't find any. If I take that off, it's going to find everything that's got a bolt in it. Okay? So even though I'm using lowercase, uppercase, I can specify the no case, and if I do that, it'll still find them, but if I do that, and it'll still find... I need to find something with a difference, don't I? Is there FA anywhere? Not huge amounts. Oh, there you go. So FA, you've got uppercase FA and then lowercase FA. So that's sort of showing that the case insensitive stuff. Yeah? Dead simple, dead easy. It's essentially one line of code with a loop. Okay? On a for each. You don't have to use the for each, but the for each is a lot nicer. The sort of nicest way of going about it. So, now we've told it where we want the data coming from and how much or what type of data we want coming back. We can now tell it what order we want that data. How do we want to see it presented to the application? We can do ascending and descending, obviously, up or down, down or up. You can specify the key, or you can specify non-keyed. You can sort of essentially do the equivalent of a read forward or a read reverse if it's a key, or just a general get the data and sort it based on a non-keyed field. And you can specify multiple fields to do the order by. And guess what happens now? Filter and order by. You should be able to guess which ones I'm going to go on. In fact, we'll have a prize of who can think the next one we're going to view. There's our little select. So here we've obviously got some sort of checkboxy radio type button things that tell me what I want to order it by, so I can set up this order by clause here. The order by option, which is an at order by. So you don't have to do it all in line. You can build the select statement up over multiple lines. I'm then going to do the select, again from the same part file. I'm not being too adventurous here. I'm doing a where clause. Now I'm doing a between, instead of just a case non-sensitive, case sensitive, check to see if something contains in a description. So now I'm doing a between values. So I'm checking that something is between 5 and 10, 10 and 15. And I'm using the order by option to tell it how I want the data returned. So if we run that, we should be able to see. Okay, so we've got the similar sort of interface again. And now if I specify, for example, 10 and 20 and click search, I only get values for the cost price that are between 10 and 20. And I can then say, I'll order it by descending quantity, ascending quantity. So I'm going from big to little, small, big to little. And I can change it and do the cost price. Very simple example, I admit, but you can see that I can do things now on the server, just bring back selective bits of information and have it ordered and sorted the way I want it to. Which means that there's an awful lot of coding that you now no longer need to do. And any developer will tell you, the less code you have to write, the sooner you can go home. I mean, go to the pub. I mean, get on to the next project. That's what I meant to say. The next project. That's what I was thinking of. Okay, so that's the sort of where we've got to with the select class. So why use the select class? Well, first of all, it is a cool way of coding. It's nice. It's OO. It gets you into for-eaching. It gets you into creating objects and understanding all that kind of good stuff. It's simple, it's easy, and it's, from a performance point of view, especially when you're using XF Server, which I would imagine the vast majority, if not everybody in this room is using, it significantly improves, or can significantly improve performance, because you're only returning the data that your application wants to use and see and do something with, as opposed to going, give me the next record, I'll do the validation, I'll check I've not dropped off the end of the file, I'll check I've not dropped off the end of the key, does the tag value still the same, does this, and is it a Monday, because if it's not, then I'm going home, sort of thing. Let it do all that for you. Sparse records. What you can also do is return little bits of data. So you may have a record that's 1,000 bytes, but all you want to do, or even worse scenario, if you think of a product item, a product record, you've got a product key, you've got a product description, and then you've got a myriad of fields about values, costs, bin locations, all that kind of stuff. So you've got 1,000 bytes, 2,000 bytes. If you want to, for your order inquiry, where you've got a list of products and you want to display the product description, you don't hold the product description on the order line, you only hold the product code. So for each order line, you're going to go off and read the product code and bring that 1,000 bytes back to display 40 characters on the screen. If you've got a lot of lines on your order, and you've got a lot of orders, that all of a sudden becomes an exponentially significant amount of data that you're bringing back from the server to the client just to display 40 characters. Okay? Not ideal. What you can then do, or what you can now do with the select class, is sparse record, which says, of this 1,000 bytes that I'm storing in the file, please only bring me back this little bit and this little bit. There can be a gap in the middle, don't have to be contiguous fields, one after the other, this little bit and this little bit. Doesn't even have to be the key that you're reading the file on. Okay? You could just bring back the description. There are some caveats why I put a demo together that demonstrates this very easily. And you can define these fields that you want to return dynamically at runtime. You don't have to hard code what fields you want. It's not something that the programmer needs to do. They can define these dynamically. So if I fly back over to my virtual machine and I select the sparse data, let's get the right one this time, shall we? Otherwise I'll blow this afternoon's demo away. Couple of things in here. What am I doing? Oh, I'm creating a field list. These are just a list of booleans that true that says, okay, those are 4 checkboxes that I'm going to have on my user interface that are all going to initially be set to true. And based on those, I'm going to say, if field list 0 is set to true, then I want to include the ID. If the second is true, I want to include the description. The third is true, the quantity, and the fourth is true, the cost price. Okay? So I'm dynamically saying what fields I want returning from my record area. I then can do my sparse record. After I've created the select, notice I'm not using the new select on the for each now. I'm defining it beforehand, and then when I've tidied it all up, got it the way I want it, then I'll start for eaching and iterating through. So I'm creating the select saying this is where I want the data coming from. I'm not doing any work clauses, I'm just bringing everything back. And then I'm saying, but I actually only want these fields, and I'm using the varargs collection. The varargs. Now this is .NET only. This one line of code here is .NET only. This where I'm using varargs is .NET only. There is an equivalent on traditional Synergy using the RCB routines where you can build up exactly the same thing. I can change this code, and I might update the Git repository at some point in time when I get some time, and show you the traditional Synergy way as well as the .NET way. I'll leave both codes in there. But you can do the equivalent on Synergy traditional as well. So we'll run that, build it, run it, and we'll get, because we set all 4 to true, these checkboxes at the top of the screen, we're getting all the data coming back. But if I say I don't want to see the key field, then I've done the select again. I've not just cleared that record out, honest. I've done the select again, and it's brought me back all the data, but it's not brought me back the ID. That doesn't mean my record area in my program is now 20 bytes shorter than it was. No, the record area is still the 1,000 bytes, but it just means the data in that bit was not returned from the server. So, although it's a fantastic feature, you do actually have to be a bit careful that you don't forget to bring data back and wonder why it wasn't appearing on the screen. I'm not looking at anybody sat over there going bright red at all. My program's not working. You might not be telling it you want that data. So, and I can sort of switch these on and off. So now I get the ID, but I don't get the description. I can sit the description back on, and I can say I don't want to see the cost price. Life is good. The cost price is a decimal. Life is fantastic. Here's the caveat. Be careful. If it's an integer field, we don't go, oh, it's an integer, I'll clear you out, because we don't really know that it's an integer, so we'll leave a naughty value in there. Okay? Now, because you've told the program you don't want that field coming back, it's your responsibility that it's got a naughty value in there. Okay? I'm just displaying it to show you that it may well have a naughty value in there. So it's not a bug, don't think it's a bug, it's a design. Okay. So, in summary then, the select class. I will now ask the question, who uses the select class? Okay, so I've not bored everybody in the room, just most of you. I'm pleased you're using the select class because it's cool, isn't it? So, in summary then, you can select the data you want, the way you want it, when you want it, and just the bits you do want. You can order it the way you want it so you don't need to worry about that in your program, and you can make your applications uber efficient by just bringing back the bits of data you want. And using things like SCS prefetch, you can tell it to bring you back whole chunks that your client can then go through, and that improves performance even more. And I think there's even talk of a future Synergy where we're going to enforce SCS prefetch. So it's not a case, it won't be optional, you'd have to turn it off if you didn't want it. And why would you not want to improve performance of XF Server? I did talk about, right at the beginning, additional capabilities, updating and delete. So you can say, for example, delete all my records. Run. Not a good idea. It's because your database is now empty. But it might be what you want. You can say, update all the records, or this field within this record where the data equals this value. That's quite powerful. I'm not going to go through the demos because I'm in select mode really. Those capabilities do exist within the API. But what we're all here for is the join capability, because it's been one of the real showstoppers of the entire namespace is the fact that we can only do it to one file. So you would have to nest selects within selects within selects. The coding gets a bit verbose, and performance has a downside because of if you're over XF Server and you're on different threads and things like that, it can get a bit slow. But now we've got the join select capability, and that allows us to say from this file join to this one, and maybe this one, oh, and this one as well, and this one to this one, and that one to that one, and join them together. And it converts then, the join select class converts a regular select into a joined select by using the select.join method. So instead of getting an item back, if you remember those demos, we did a for each of a record area or a structure, and we went through and displayed the details for each one of those record areas or structures. We don't get that anymore with the join select. We get an object called a rows back. And a rows comes back and it contains your rows information. And your rows information contains all the records that are joined together for that particular row. Okay? And you can also do the sparse record, sparse return and things like that, so you don't have to bring all the data back. And the rows object, as well as providing access to the actual data, there's various properties and attributes on there that allow you to say, is this data what I want? Has this data changed? Is this different? And I'll sort of talk about that when we go through the couple of examples, because on the face of it you think, well, I've asked for the data, it must be what I want, and it must be data in there. Well, it's not always going to have data in there, depending on the types of joins you've done. One of the big things to know about this, because I know you're all going to start using it today, tomorrow, the moment you get back into the office. 99% of the time, when we add stuff to Synergy, the next version, 99% of the time it's in the compiler. Inline lambdas is in the compiler, okay? So you can code using inline lambdas and target an older runtime because it's compiler technology, not runtime technology. Unfortunately, the select join is a runtime technology. Therefore, if you want to use select, you will have to upgrade your runtime environment, as well as your development environment, obviously, but you will have to update your runtime environment to 10.3.3. For me, that's not a bad thing, because that means you're going to be using the latest and greatest runtime tools and capabilities, as well as the latest and greatest developer tools and capabilities. I think this is one of the reasons why we won't get immediate adoption of it, but it will make you want to upgrade to 10.3.3, because you're all going to do that after this conference, aren't you? As Roger briefly mentioned, we've got this select on, and you use the on class to join two files together, and basically you're saying join here on this bit over here. And the on basically allows you to define the connection between primary file and the joined file of the joins that you want. Roger did mention, and I will reiterate it, the way you access the join file has to be a key. If you're not a key, you will get an exception thrown. It doesn't just sort of not bring any data back, it throws a big nasty exception. It has to be a key. So you can't say, for example, join to a file where something in the description might have a value of Fred, okay? Because something in the description isn't a key. It has to be a key. The rows class then, Synergex Synergy select rows, allows you to access the record set for each row. And associated with rows is a row info. And that basically allows you to get at metadata around the return data rows to help you identify should you actually process a row that's been returned. Because when you're iterating, for example, through a join, a left join, there may be data that hasn't changed for the right-hand side. Say you've got an order with lines. If you say, bring me all my orders and all my order lines and join them together, you'll get order 1, order line 1, order line 2, order line 3. Then you'll get order 2, okay? But for the additional two lines, line 2 and 3, you wouldn't get a new order header. Okay, the order header would be null. We don't bring back 3 order headers if it's got 3 order lines for the one order. We bring back 1 order header and the 3 order lines. So as you're iterating through, that will be 3 iterations through your rows, but your second 2 will be not changed. Okay, so that's what that row info attributing allows you to do. Has the order header changed? Oh right, I'll have to do some processing because I'm on a new order header. No, it's not. I must have a new line. I must have a new line. I must have a new line. Okay? So the two sort of joins we handle. In a join, the results are you can select all records from both tables as long as there is a match between the fields on both sides. And you'll sort of use inner joins for saying, here's a order line with a product code on it. Go and find the description from the product ID from the product file. Okay? So you join that sort of join together, which is probably very similar to the example I might be showing momentarily. It's time for a demo again. So let's look at the code, because when you put codes up on slides, it can be pretty difficult to see. I've changed the program a little bit, so we're not on just list of parts now. So at the top of the screen, I'm going to show a list of suppliers, so we can see all the suppliers in the file. There's only a dozen suppliers, so there's not exactly huge amounts of data in this database, example database. So obviously there's no joins going on there. And I've actually got two tabs going on. But here is where I'm going to do the join. So my result set, but that's an at rows, okay? So I'm going to get an at rows back as I iterate through my joined select. So I'm going to do a select. I'm then going to tell it where I'm going to get the primary data from, which will be my suppliers. And then I'm going to do an inner join on orders. Okay, so I'm going to do an inner join with a from to tell it where the data is coming from. And then I specify the on. So this is the connector. It's where the supplier ID equals, that I'm reading from the supplier file, equals the supplier ID on the order header. So I'm basically filtering and saying, for each supplier, just bring me back that supplier's order header details. Okay? And the dot join here, this method here, that is what changes the response of the select from an item, i.e. a record or a group or a structure, to a rows object. I can then iterate through my rows object. First of all, I'll get some row information to say, has the supplier changed? Now, the way this works is, because you specify the supplier here, and it knows that's the primary table, then it sort of remembers that record area position or that structure position in memory. So I can pass it here and say, did this data that I've requested, has it changed? If it has, then I'm on a new supplier. Obviously the first one, the first iteration through, it will have changed because that'll be the first supplier. But I may have one supplier, multiple order headers. Next supplier, multiple order headers. Okay? And I only want to do something with a supplier if I've got a new supplier record as I'm iterating through this collection. You don't have, it's not like you nest your iterations through. Okay? You get all, it's as though you get all the data, but we say, by the way, this one's blank at this time, this one's null here, this one's null, it's not changed, it's the same as it was last time, so don't process it. So if it is changed, then I'm going to do something with the supplier details. If it's not changed, or it had changed, both instances, I'm going to then do something with the order. So I'm going to basically build up this collection which contains mini collections. Collection of suppliers, and each supplier has its own collection of order headers. Okay? So if we build and run that, that was the first select. Give me a list of all the suppliers, just so you can see there are suppliers in there. And then on the second tab, I've said, okay, give me all the suppliers that I've got order headers for and display them. So now I only see two suppliers, which means I've only got orders in the system for two suppliers of my 15 billion suppliers that I have. And here is the order headers. So for Bendix, I've got 4 orders outstanding, and for EBC, I've got 1 order. So, but to iterate through this, I would have iterated 5 times. Okay? The first iteration would have said, yes, I've got a new supplier, it's Bendix, and yes, you've got a new order header, and it's order 3621. The second iteration, it would have said, your supplier's not changed. Oh, right, therefore I'm still on the first supplier, but I've got a new order header. I'll do the order header. Third iteration through, supplier's not changed. Fourth iteration through, supplier's not changed. Fifth iteration through, supplier's changed. Oh, right, I'll create a new supplier, and then I'll start adding the next rows, the next items to come back into that supplier. Okay? So that's the way the rows and the iterating through works. Is that as clear as mud? Good. Don't even wait for a response anymore. We'll just carry on. So, next thing then, left join. All records from your left table are returned, Any matching records from your second or joined file will be returned also. I think I've got 2 more demos. So here, I've gone away from suppliers for a minute. I am going through my parts list, and against the part, I've got a part ID and description. I've also got a group ID, what group that part it belongs to. But I don't want to display the group ID, I want to display the description of the group. So I'm going to go through, I'm going to load all parts, and then I'm going to join each part to its associated group. And then I can display the group information instead of the group ID as though it's sort of all one record. Okay? And I do the join with the on to say the parts group ID equals the ID of the group, and do the join. I don't need to test if there's any has changed, because I will be getting all the part records and all matching group records. Okay? So it's a very simple example of a left join. So what I've got here, you'll be able to see it better now. I've got the ID, but now I've got the group, that should say group description. Okay? So these products are all part of the group that's defined as devices to aid slowing and stopping. Pretty important really when you're riding a rather fast motorcycle. You like to be able to stop occasionally, preferably not by brick walls. But that devices to aid slowing and stopping only comes back, I believe, only comes back once. Even though I'm displaying it 30 times, I'm only getting it once. If I was to code this without the select and the join capabilities, I'd end up rereading the record unless I stored my own local copy and did a sort of a lookup on it and all that kind of stuff, created a dictionary. So it helps you out an awful lot. So you can join data together. So I've got a couple more slides and one more demo, and then I shall open the floor for questions and then run and hide under a curtain or something like that. Multiple joins then. The world is now your oyster regarding joining things together. So the next example, we're going to start off with a supplier. We can order and filter that supplier if we so desire. We can then join, as we've already shown, to the order headers, so get all the order headers for a particular supplier. And then we'll break that down and we'll say, well, bring all the order lines for each particular order, for each particular supplier. And then the order lines have got a product code on them. I don't want to see the product code, I want to see the product description. So I'm going to join the supplier to the order header, to the order lines, to the products. I want to talk before I do the demo about analysis. Very simple slide. Analysis, you set the 2 environment variables you can see on the screen there, dbg select file, and that puts information about how the select has been built, not how you've written it, but how it's been built by the runtime and how we've accessed files and what records we've read and how we've read it, what keys we've used, etc. And you can use that information to analyze what's happened and go, oh, hold on, if I change that, I'll then be using a key as opposed to not using a key, and things like that. And why is it bringing so many rows back there? Oh, because I should go on a key or add a tag value or filter it somewhere. So you can use that as information. It's not, well, yeah, it's good. See what it's doing, optimize your select statements. So I'm going to now do a demo, and the code is essentially one line of code. It might be physically split across multiple lines, but it is one line of code. So if I look at complete, so here I'm doing that, you can't quite see it all, but hopefully you'll get the gist of it. So I'm doing get everything from the suppliers, so read through my entire suppliers, inner join the supplier to the order header. So this means I'll only get the suppliers back that have got order headers, and join the supplier ID to the order header supplier ID. Then inner join to the lines. So if I actually had an order without any lines, I wouldn't see the order, but hopefully in your system you've got order header and order lines, and they're all in place. So the order number then from the order header I'm using to join on the order detail. And then I'm doing a left join that says I've got an order detail with a part number on it. Go and find the part information and return me that so I can display the description. Okay? I'm then going to, I've got a hard-coded no-case word that says only bring suppliers back with the name B in it. The fact it brings back the 2 suppliers that I've got is immaterial, but never mind. And then order by descending. So I've got pretty much everything that you can do from a read selecting point of view in that single line of code. As I said, it physically spans half a dozen lines in the editor, but I'm using the and ampersand, therefore it's one line of code. I've not got multiple loops and multiple key lookups and multiple reads and set this key value and check that I've not dropped end of file and all that kind of stuff. It's one line of code to get the data. You then have to say, well, as I'm iterating through my rows collection, has the data changed on my head primary and subsequent tables that or files that I'm returning? So I'm going to check, has the data changed on the supplier? Has the data changed on the order header? If it has, then I'm going to have a new section of the orders headers and add the lines to it and add the order line information and the part information. So you can see you can build things up. This code here is just building up the way you want your application to see it or present it. Okay? You don't have to sort of do this all the time. It's just the way you iterate through the rows collection. So hopefully this will build and we'll get a nice little demo of it. We've looked through the code, but basically what we've got here now is the suppliers at the far left. We've got the name of the supplier, then we've got that supplier's order numbers, then we've got that supplier's order lines, and then we've got the part description from the part file. So this demo is basically cascading down as that graphic showed. Okay? Very, very straightforward, very simple, but it shows you how easy it is to concatenate all this information together, join it all together, and present it to a nice, semi-nice user interface, straight out of the box. This is just simple WPF. And this is the log file that's created. So it tells you what files you're getting the data from, how you're getting the data. It doesn't give you field names, it gives you positions within the record. So a 7:20 as an alpha and 1:20, etc. Okay, so you can see that what data is being used to get at what. Key ranges. Now, there are some things about these total rows fetched. 26 out of 26. That's not quite right, and John did explain to me why, because I did I did a work clause on an alpha, so that's right, it did have to go through all the suppliers, because I did does it contain B in the name? Obviously, does it contain B in the name is not a key, so that's why I've got all 26 records. Because I would look at that and go, well, why have I had to search through all 26? Well, because I could then go back to my work clause and say, could I optimize this? Could I change it? Could I make it a bit better? So that information is available to you. And that's the results from the one line of code that you issue to our, essentially our data server, ideally through XF Server, and return all the information to you. Are there any questions?
Yeah, does this imply that you would use the code gen to actually create your data objects? Because it was easy for you just to say, oh, use the order object, use the supplier object, use the product object, but it implied that all of that was in place to make it, not saying that's a bad thing or anything, but does it assume that you're using this in a context of creating those through CodeGen?
The question is, why am I doing it the way I'm doing it? What Gordon's talking about is, and I'm just trying to get my mouse going so I can close the program. Let me repeat the question and answer the question at the same time. Gordon's talking about these data objects here. And a data object, for those of you who were there yesterday or have been before, we're talking about Symfony Framework data objects. I've used them because it's just a simple way of me to present information to WPF and things data bind together. They don't have to be data objects. If you're going to use a data object, then yes, you will code generate it. But they don't have to be. And in fact, I'm only using data objects as a mechanism of presenting the information to the WPF, the user interface. The fact here is supplier is a structure, which is exactly the same as a record area, which is exactly the same as a group. That's not code generated. Okay, in this instance it is, but I could have included repository supplier, structure name supplier. So I can use the select class without data objects, without anything like that, with just pure And I can only use them with pure record areas, structures, or groups. But then I'm moving those into these Symphony data objects to then say, here WPF, display them nicely. If you wanted to use that information to go into a report or display on a WinForm or on a toolkit application, no difference. So data objects are only used from a get data onto the screen point of view, nothing to do with the select class. So does that answer your question? There was another one over here.
In your example there, if you had an order line with no product in it, what would have the resulted output look like?
If the question is, if I had an order line with no product in it, what would the output look like? Empty? It would just be an empty field, empty record area, because it couldn't join anything to it, I would imagine. But why would you have an order line with an item on it that you've not got a product for?
You have an order header without an order line, though.
Yeah, so you'd only get the order header. It wouldn't fill any order lines in. It would still work. You just wouldn't get any order lines, like you wouldn't get any product information. Yeah, but it would work. Unfortunately, my data's pristine, super, and everything, so I can't demonstrate that. I'll put some bad data out there.
Yeah, Richard?
Yep.
The efficiencies understood of joining on keyed fields, that's understood. Do you think that that'll always be the restriction? Is there any possibility of actually joins where sequential, certainly we know it's inefficient, but being able to do a join on an unkeyed field, not in the landscape at all?
Okay, the question is, will we ever be able to do a join on a non-keyed field? At the moment, the answer is no. The restriction is there purely to prevent you going down a performance black hole. It really is.
Assuming we stay pristine and we stay on the key fields in the on part of the join, the net result after the joins, are all those fields available to the where clause, or is it only that top level table?
So the question is, if you have, are the fields in the join available to the where clause?
Correct.
Yes, I believe they are.
Any other questions?
The data set that you had there was obviously only small.
The what set?
Data set.
Oh, the data set, yeah.
I won't throw the mic yet. Have you done any performance sort of comparison between doing a similar, in what you did there with the join and the select, to doing it traditional way where you would go and read all the records, return them all back, filter them yourself on the client and on a bigger data set?
The question basically is, have we done some performance analysis comparing doing selects and joins instead, as opposed to manually written lines of read S. I have done some, and it's a lot faster, but then I purposely made my code really bad and slow. It took me a long time to write that, but I got there in the end. I copied a couple of other people's. I've personally only done simple tests, but we can certainly put some together for you. Oh yeah, my stuff was a huge improvement, absolutely huge improvement, especially when I was using XF Server. Huge improvement. Scale of magnitude of 2 easily. 2? 3? I don't know. No, it was a lot faster. Is that it? Can I go now?
Anybody else?
Okay, thank you very much for your time.